Okay, the other option when wanting to store strings in an array that have different lengths is to use the character command or the char command. So you can basically do everything that we did at the end of the previous video, where you just ask for the as you create the array string, you just create it using the expression char. So you can see we have first, last, middle, just like we did last time, except with no blanks. And the fact that we're using the char command, we're storing that array in lab. Then you can see that what lab is going to display is first, last, middle. There was no need to enter blank spaces. And you can also see that we requested the size of lab, and so what the output is for the size of lab is that lab has 3 rows and 6 columns. So that's a convenient and more efficient way to store a series of strings in an array. Also, I do want to point one thing out. There is a typo in this particular row right here. The way this is typed in, you would not get this display. This display would only occur if you had semicolons here separating first, last, and middle. So that's just an error in the slide that you need to make a note of. All right, you can actually remove leading and trailing blanks with an expression called string trim. So we can use string trim of S, and that'll remove any blank spaces. The comparison of 2 strings can be made by using the string compare, strcmp. So if you store the output of that into an array called L, and you compare 2 strings A and B, then the output of L will be true if A is equal to B, if A and B are the same. It'll be 0 or false if A is not equal to B. And so this function is intended to compare character data. And by the way, before I leave this slide, let me say that this could be useful in the upcoming project. So let's suppose you have 2 strings that are defined in a script. In this case, the string in A has 2 additional leading blanks and 2 additional trailing blanks compared to string B. And so in C1, we just want to do a string compare between A and B to see if they're the same. And if you don't do anything to A and B, you'll get an output of 0 because they're basically not the same, because MATLAB is interpreting blank spaces as characters. So if instead of that, you use the string trim command, so what that's going to do is that's going to eliminate all of these blank spaces and all of these blank spaces, all of these blank spaces, and all of these blank spaces. So it eliminates all of the blank spaces, and basically then when you do string compare between trimmed A and trimmed B, you get a statement, yes, they are equal. This is particularly useful if you're using user input and the user, for whatever reason, accidentally inputs a space before or after they enter the choice in their string. And I'm sure there are other applications as well where this would be pretty useful. It's pretty easy, as you know, when you're interacting with the keyboard to inadvertently enter a space. All right, well, it's possible, and you've also seen this command before, but it's possible to convert numerical values to strings and display them. So to convert a numerical value to string, we just use the expression num to string, and then we put the numerical value in the parentheses. You can also specify how many digits you might want to display. So this is particularly useful if you've got something stored in MATLAB that has an excessive number of digits and you just want to, say, display the first 3. Then you can do that by using whatever your numerical value is, calling that calling either a number or an array of numbers or an expression, and then N, capital N, limits the number of digits that get displayed. So here's the syntax on that. Z is going to be a string. Num is either a number, an array of numbers, or an expression that results in a number, like some kind of equation or an expression that results in an array of numbers. So n can be n is an array or a number, or like an algebraic expression. And then z, the output of z, comes out as a string. So here's an example of what that looks like if you vary n for a given string. So we're going to let a be 1000 pi. Here's what comes out and gets stored in a. And then if you want to display that, some of your options are you can display a only showing one digit, you can display a showing 3, 4, 5, 8, and so on. The decimal point does not count as a digit, but MATLAB will insert it. Now, if you want to convert an integer to a string, If you want to convert an integer to a string, so sometimes, as you know, things are stored in MATLAB as integers. If you want to convert an integer to a string, then you use the integer to string command, where in this case num is an integer. If num is not an integer, then it's rounded to the next integer. So for example, if you had 3.7 or minus 3.7, it's going to be rounded to minus 4. So a typical construct is to use num to string to concatenate the converted numerical value with some kind of identifying text. So let's say num is a weight given in kilograms, and we want somehow in our code to identify that that is a weight. So in that case, if you know what your value of num is, that of course is stored. So what you can do is, and we've done this before in some of your projects as well, so this should look familiar. You're going to create an array, and it's going to have a string that says product weight equals, and notice there is a space here inserted after equal. And then you have your num to string command of your num, so this part is going to create an element in the array of 12.576, converting this number to a string. And then finally, you'll have a space kilogram, which is going to display also as a string. So notice these are in parentheses, or are separated by a single quote. This one is not, because it's doing the num to string conversion. So after this line of code executes, we'll get product weight equals displayed. There will be a space. We get 12.567 displayed from the num to string command, and then we get another space prior to the lowercase k in kilogram, and then we get kilogram displayed. So just to note, at least one blank space on each side of num to string is required. To create annotation that accompanies each value of num, you can use the command called repmat. What this does is that this replicates and tiles an array. So if you look here, we have this right here, repmat object length equals. So what that's going to do is that's going to display object length with every element in the array num. So notice num is a column matrix. So if we were to just display the string of num, we'd get this column here. And so what we want to do is we want object length and we want meters displayed in each column. So basically what's going to happen is this is going to display object length in number of times. So it's just, and then the semicolon here, of course, is telling it to go to the next row. So it'll display object length, it'll display the first row of num, it'll display meters, and then you've got a return, so then it's going to display object length again because it has this repmat command. So it's just a convenient way to repeat a string over a series of rows. Now you can also do, you can use this command not just for strings, you can use it for arrays themselves. So notice we have repmat, and then I is the identity matrix. The identity matrix of 2 is 1001. So notice we have rep mat, and then we have the identity matrix, and we're telling it to do 3 rows and 2 columns. So here we go, 1, 2, 3 rows, 2 columns. It basically has repeated what's in the brackets. An alternative way to display formatted data in a MATLAB command window is with fprintf. Fprintf is complicated syntax because it uses certain characters to specify what format you want to use with fprintf. At this point in time, we're not really going to go over fprintf in great detail other than to show you the general syntax. So 1 in fprintf indicates that the output goes to the command window. The % is a format specification pertaining to the variables, and it precedes each format specification, and the format specification is of the form x.yq, where q specifies the format, x specifies the minimum number of digits to be displayed, and y specifies the number of digits to the right of the decimal point. So it's a pretty complicated command, and the syntax can be pretty complicated. So in this case, we defined a number here, and this is just an example of how fprintf works. To be honest, I don't particularly care for fprintf, because typically if you're going to play around with things that do complex things in displays, you're probably not using MATLAB to do that. You're probably writing MATLAB to another kind of software, and then you're using that to do your display. But nevertheless, it is very powerful. So here you can see we have percent 5.2. So the 5 is the number of digits. The 2 is the number of points after the decimal place, and 5, notice, is a maximum number of digits. So when we have 12, what it's going to print is it's going to print 12.00 because we've specified to have 2 digits to the right of the decimal place. F stands for fixed point format. \m or \n is like a delimiter that, when executed, takes your display and puts it in a column. Somewhere I have a summary. I may need to pull that up on MATLAB itself, but if you type in help fprintf, you'll get all of these codes, like what does f mean, what does n mean, etc., and it'll tell you, all the possibilities for using the fprintf.